Let's find the molecular formula for each compound. We're given the percent composition information as well as the molar mass information. Let's first get the empirical formula. Percent composition is an intensive property, so it doesn't matter how much of it you have, the percent composition of a compound is going to be the same. So the easiest numbers to work with is if we assume we have a 100-gram sample of each of these compounds. So if we had 100 grams of compound A, then the oxygen component will make up 94.1 grams of the compound. And we want grams because we want to turn that into moles. So the molar mass for oxygen from the periodic table is 16.00. So let's use that molar mass to convert to moles. So we get 5.88 moles of oxygen if we had 100-gram sample of this compound. All right, now we're trying to get moles because in order to get the empirical formula, we need O with a subscript of something and H with a subscript of something. So these subscripts can be interpreted as mole ratios. That's why we're trying to get moles. If we had a 100-gram sample of compound A, hydrogen would make up 5.9 grams. So again, we're going to use the molar mass of hydrogen off the periodic table to change that into moles. We have 5.85 moles of hydrogen. So you can see they're almost identical. So therefore, the mole ratios are equal. The empirical formula is equal to OH. So now that we have that information, we can see how many times the empirical formula mass goes into the molar mass. That'll give us the molecular formula. So let's find the empirical formula mass. So oxygen has a molar mass of 16.00 and hydrogen has a molar mass of 1.01 if we round to 2 decimals. So the empirical formula mass of OH is 17.01 grams per mole. So we're given the molar mass of 34. So the empirical formula mass goes into the molar mass 2 times. So the molecular formula is 2 times the empirical formula. The answer to part A is H2O2, or hydrogen peroxide. All right, let's do B the same way. We're going to assume we have a 100-gram sample of B. If we had 100-gram sample of B, 50.7 grams would be carbon. And let's turn that into moles. Carbon has a molar mass of 12.01 grams per mole. We get 4.22. moles of carbon if we had 100 grams of the sample. We would also have 4.2 grams of hydrogen. So that's 4.17 moles of hydrogen in a 100-gram sample of compound B. And 45.1 grams would be oxygen. So we get 2.82 moles of oxygen if we had 100-gram sample of compound B. Now the next step is to take the lowest result, which is the moles of oxygen, and see how many times it goes into each of the other results, including itself. And the reason we're doing this is because this guarantees one of these decimals disappear. Because right now we have an empirical formula of C 4.2, H 4.2, and O 2.8. And you can't have decimals in a formula, so this is no good. We're trying to turn them into lowest whole number ratios, called the empirical formula. So 2.82 goes into itself one time. So that's very close to 1.5. So these results are usually going to be very close to whole numbers, a half, a third, something pretty obvious like that. And this is the same deal. So we're not done yet because these are still not whole numbers. So we'll multiply through by 2 and we'll get the lowest whole number ratio. So the empirical formula is C3H3O2. So now let's get the empirical formula mass. Carbon is 12 times 3 is 36. Hydrogen, there's 3 of them, so that's 3. And oxygen is 16 times 2 is 32. So the empirical formula mass of the compound in part B is 71 grams per mole. So we're given the molar mass information, 142. These are always going to the molar mass a whole number of times because the molecular formula is a whole number multiple of the empirical formula. So 142 over 71, the empirical formula mass goes into the molar mass 2 times. So the molecular formula is 2 times the empirical formula. So the answer is C6H6O4. Just 2 times that. All right, finally, part C. Again, if we have a 100-gram sample of compound C, we'll have 56.6 grams of potassium. Potassium has a molar mass of 39.1. You get 1.45. And if we had 100 grams of compound C, 8.7 grams would be carbon. That's 0.72. I meant to put moles of potassium up here. And cancel out the grams. All right, and finally we would have 34.7 grams of oxygen. Turn that into moles by using the molar mass conversion factor. It's 2.17. So carbon has its lowest result, so we're going to see how many times that goes into each of the results, including itself, because that's going to at least guarantee one of the decimals disappears. So at this point, we're left with whole numbers. So this is the empirical formula. K2CO3. So let's get the empirical formula mass. Potassium is 39 times 2, 78. Carbon is 12, and 3 oxygens is 48. So the empirical formula mass is 90 plus 48 is 138 grams per mole. So let's see how many times 138 goes into the molar mass given. All right, well, it's nice. It's the same. So in this case, the empirical formula and the molecular formula are the same.